Okay, hi and assalamu alaikum. Welcome to this short training on statistical analysis and reporting. Hope you are doing well. And if my voice is clear, just reply in chat box, or you can also open your microphone. Is okay. Um, my voice is clear for all. You hear me? Okay. Thank you so much. Um, this is a basic. This is introduction part of statistical analysis and reporting. Hopefully, in near future, can also, if you are interesting, we can also um, conduct another basic analysis by SPSS or maybe by Excel or also GraphPad. We can do. And also, if you are interested more, we can conduct an advanced level of statistical analysis. But in this session, we are going just the basic thing and introduction. Uh, Also, I am trying to make some short videos on uh, how to do a statistical analysis in practical way by um, using SPSS and upload to my YouTube channel. You can also have this short videos hopefully in near future on my YouTube channel. So this is just an introduction part. Hopefully you can finish by around 1.5 hours. Maybe if you have any question, maybe take 2 hours, but we try to squeeze it and focus on the main things during the uh, presentation. If you have any question, just open your microphone and you can ask. Also, my chat box is open. You can put the question in the chat box. Okay, so um, for the starting, I want to describe about something differentiate between mathematics and statistics. For example, this is a mathematical relationship. Y is equal to 2x plus 5. If I give the x equal to 2, all of you will reply the correct answer as 9. If change to 3, you also change it to 11, for example. So here we have just one exact uh, result. By giving the x equal to 2, we have just one exact amount of y. Y, as you know, is independent variable, and x is a dependent. Y is dependent variable, and x is independent variable. We change the x and measure the y. In this is in mathematics, so we have precious result. We have one x. All of you will, if you are learning the basic thing, you will calculate the y or dependent variable at exact amount. But in a practical work, uh, if I give you a food sample to measure moisture content, I will give you x. X is the food sample, and you measure Y is moisture content. Um, are you giving me exact amount of the moisture content? I'm not sure that all of you reach to exact one data. Maybe one give the 24%, another person give 25, another person 26. So here you can see we have not a precious and a single uh, result for Y. Y is moisture content. So if I give you a food sample, if you even you if you repeat, maybe you cannot find exact same Y or dependent data for the uh, moisture content. Why? You know, why you have not reached, or you and your friend cannot reach exact same uh, result? Why? Because we have error. We have error in measurement. We have in the practical data, we have uh, different types of errors. So um, we due to errors we cannot reach the exact same data here. The errors comes from, we have three main source of errors. The first thing is personal error. um, Due to human eyes, human measurement, human sensitivity, um, we have different types of errors. If we are um, measure something, and if you triplicate, you will receive maybe another data. Why? Because we have personal or human error. Uh, if you want to measure, for example, the acidity of a food material by changing color from, for example, white to purple, different eyes can detect different range of the purple. So this is the reason that we cannot reach to exact amount. The first and the main errors coming from human error or personal error. Each person have different types of error. The second source of error is coming from the instrument. Instrument. Instrumental error is the second source of the errors. For example, if I give you a sample to measure the moisture content, maybe one student going to use the oven method, another student going to use the TGA, thermogravimetrical analysis, or maybe another student going to use the different method, different types of method, different uh, equipment. Different equipment have or instrumental have different errors, so you cannot reach to exact same amount of the uh, data. So the second source of errors is instrumental, and the third method is um, third. Oh, okay. Third source of the errors is method method that you are using. We have different standard type. One person refer to ASTM method, American standard. Maybe another going to refer to using ISO method. One person going to national standard. Maybe another going to reference using reference from literature or from another source. So different method, different error. So uh, we have uh, three main source of errors coming from personal, instrumental, and method. Different method, different. So in combination, it together, or maybe we have also etc. Source of the errors, but mainly these errors reach that when we measure um, in a practical method, we cannot reach to the same amount of the um, data. So for this reason, if I give you exact same sample to all of the student, they will give different amount of moisture content. Why? Because of this source of the errors. Now, how you want to report moisture content? So here, how you want to report? Here, if x is equal to 2, you exactly put y equal to 9. But here, if I measure the by this data 24, 25, 26, how I'm going to report the moisture content? Should I report 24, 25, 26, or we need a representative? I think we need a representative here. A representative is basic things that we need statistics. So in statistics help the researchers to report the data or report the representatives for their measurement. So here, because we have not in the repeating an experiment, we have not exact same data. For this reason, we need to report a representative. How we can report the representative? We need a statistic. A statistic science is divided in two uh, parts: descriptive statistic and inferential statistics. Uh, Descriptive statistic give you central tendency or central indexes, um, and or dispersion or maybe variability is in descriptive statistic. So we have two types of index: central index and dispersion index or variability. In inferential statistic, we test the hypothesis. We test the hypothesis, and I am describe this one in next steps. Okay, so the first thing, starting by descriptive statistic and central tendency. In central tendency, we have uh, three main uh, central index: mean, median, and mode. Uh, Here, the mean of the bubble. So, the best thing that we report uh, for the representative of this data to report a representative or central tendency. Now, the best thing, the best or direct or easiest way is to reporting the mean of this data. The 24, 25, 26, we uh, sum up and then divided by the number, and it equal to 25. So we report the mean of this data as representative um, for the moisture content 25%. Okay, so please go to menti.com and enter the code 890484. Please go there and okay, please come here and calculate the mean for the following data 1, 10, 100. Please come here, go to menti.com and use the code 890484. Okay, okay, six answer. Okay, come on. We have 31. We need to load 31 participants here. And okay, 37. All of you. 37. Okay, okay. 12, 37. Okay, another student in chat box mentioned that 49. Why 49? 49. Maybe it's a possible answer. Okay, please come, Stephen, come to respond to this. Um, okay, please come. 19 reported, all 19 reported 37 and one in chat box. The Kuan Liang mentioned that 49 also is a possible answer. Um, okay, so um, 20, all 20 plus 1, yeah, represent that 21. Okay, come. I want to, okay, 37. You have not any other choice. Okay, 23. Okay, I want to go to the next question. Please come. We have another question here. Just I want to check your feedback. Okay, 23 replied by 7. Okay, so I'm going, nobody going to reply. I'm going to the next question. Is it okay? Awaiting you. Please come to reply. Oh, 1%, 10. Oh, okay. 23. Okay, now we have uh, three choices 1, 10, 14, 1, 49, and also 23. Our students reported as 37. So I'm going to the next question. Um, Okay, in this question, um, from Penang to Ipoh is around 120 kilometer, I think so. 120, like 24 kilometer. A car with 60 kilometer per hour going first 60 kilometer and no, if you divide it from Penang to Ipoh in two parts, um, okay. The first 60 kilometer going by 60 kilometer per hour, the car. And the second 60 kilometer going by 120 kilometer per hour. What is the average velocity of the car? So half part of the uh, half part going by 60 kilometer per hour, another half going by 120. What is the mean um, between 60 and 120? 60 and 120. So one person mentioned 60, 390. Okay, come, come and reply. Okay, well, okay. Half part 60, half part 120. What's the mean average velocity between 60 and 120? 60 kilometer per hour and 120 kilometer per hour. What's the mean? Yeah, 90. Okay. Oh, 120. Um, I want to describe here one major note that if we have different data, the mean uh, shouldn't be exact one of the data. So when we have 160 and 120, the mean will not be 60 or 120. It should be between these two. So I'm sorry to say that the 60 and 120 is not correct. If you want to make mean between different data, if you want to take mean between two data, um, and the data is different, for sure the mean will be between these two. Or if you have three data, four data, any data, um, so it will not be the first and the last. It should be between the in the range. So 17 our student replied 90, 120, 160. Okay, so any other reply? This one for the average velocity of the car here. Okay, very good. Thank you so much. I am going to um, continue the basic statistic here. Okay, central tendency of 1, 10, and 100. Most of you mentioned that it's 37. Um, Here, when you want to choose a central tendency, here we are looking for a representative. You think that 37 is representative of this data? I'm not sure that the uh, 37 or even 49 other student represent the as representative of the data, because it's not central tendency. No central tendency of this data. 1, 10, 100. I think which of them is the central tendency here? The best central tendency is 10, because it's more accurate to be representative of this data. Usually, when you measure the microbiological measurement, because you're using mostly a dilution part of by 10 times, and your data have different by 10. One is 10 power 10,000, another is 100,000, another one maybe is 1 million. So if you want to take the um, central tendency, the best central tendency for these types of data, that the data is coming basically from a decimal changes, or maybe in multiply by one number. Here this data is multiplied by 10. So if it's multiply, you cannot use this type of the mean. We call this type of mean as a arithmetic mean, that you sum up and then divided by the number of the data. But here, when your data is coming from different measurement, from different type of measurement, like microbiological data, or maybe other type, that if it's not um, changing by one small interval and having a multiply by a number, here you need to use another type of mean. Mean, we have arithmetic here, that we sum up and dividing by the number. Another type of the mean is geometrical mean. In geometrical mean, we, instead of the sorry, instead of the summing and dividing by 3, we are going to root third. And how many data we have? 3. So going to third root. If we have 4, going to fourth root. If we have 5, going to fifth root. No, here we uh, are going to take the third root of, instead of the adding, we multiply. 1 multiply by 10 multiply by 100, and take the third root is equal to 10. So if your data coming from rheological measurement, and you cannot take the mean, the arithmetic mean, it's the best representative is this one. Also, another way maybe you learn in the microbiology, you take log, and then after that using the arithmetic mean for the log of the data, and then after that back converted to the um, origin. Here take the log 1 is 0, log 10 is 1, and log 100 is 2. We have 0, 1, and 2. And if we uh, sum up, 0 plus 1 plus 2 is equal to 3, and then divided by 3 is equal to 1, and then we take antilog. Antilog will be 10. Maybe you also learn this one in microbiology, to take the mean. It's same as the geometrical mean. This way is easier. You take the number root If you have three, third row, four data, five data, it's depend. Uh, Root number will be changed by the number of the data, and instead of the summing up, you need to multiply the data. So it will be 10. So just one of you replied correct answer as 10. Another uh, question arises here. When we using the uh, car going by 120 kilometer, for example, from here to Ipoh, to Penang to Ipoh is 120. The first 60 kilometer going by 60 kilometer per hour. Another um, time, another second or second part, second 60 kilometer going by 120 kilometer. The average velocity, if you take 60 plus 120 divided by 2 is 90 kilometer per hour. You know, you take this one. But come to the physics. The average velocity is total distance divided by total time. Total distance is 120 kilometer. The first 60 kilometer we went by 60 kilometer per hour. So 1 hour take time to pass from the first 60 kilometer. Another 60 kilometer we went by 120 kilometer per hour. So here we went 60 kilometer by half an hour. So the total takes time will be 1 plus 5 is 1.5 hours. 120 kilometer divided by 1.5 is equal to 80 kilometer per hour. Now here, if you take the 60 kilometer and 120 to mean, it gives you 90 kilometer. But if you using the physics, the real average is 80 kilometer per hour. Why? This is the difference between you. Um, Fatin, please close your microphone. I've closed. Um, here, what wrongs here? What's wrong when you measure the um, mean? 60 plus 120 divided by 2 is 90. But the real average velocity is 18. Why? Because we have not used the uh, you know, appropriate mean. Um, this one, if you are measuring some data, it's based on the hour or maybe based on the day, based on the year, based on something, some distance, some specific distance, or some specific time. If we repeat or if we measure, for example, measuring the rate of a reaction, it's per hour, per second. If it is per hour or per second, or maybe sometime per distance, in a if some measurement, if some measurement uh, measuring based on the fixed rate, fixed time, or fixed distance, you are not allowed to use the arithmetic mean that you plus together, sum up, and divided by the number. So in this case, we are using harmonic mean. Harmonic mean using when you your data is measuring in a fixed distance, fixed hour, or maybe it's a rate. If you measuring the rate, you cannot using the arithmetic mean. You can see that we have different amount of the 10 kilometer per hour different here in a 120 kilometer. And if you are doing some maybe measurement that based on time, you cannot use the arithmetic mean. Here, you need to refer to harmonic mean. This harmonic mean in food technology we're using for rate of reaction, something like that one. But commonly in the social science, economic, it's very popular to using the rate of inflation, the rate of population growth, the rate of death, everything over there because it's based on year or maybe based on month. For this reason, if they want to take the mean, um, then the mean will be lower. Sometime maybe government report that our rate of inflation is, for example, 80. But when you calculate by hand, it's 90. Why they report 80? Because the correct way here is different. Because the um, harmonic mean using for this case. In harmonic mean, if we have data like this one, we have 120, 120, 60, and 120. So we have two data. So two data, the number of data coming here and instead of the adding together 60 plus 120, we inverse the data. 1 over 60 plus 1 over 120, and we divided the number of the data to this addition. It will be 80 kilometer per. So in this case, we have three different types of the mean. We have arithmetic, if the data is in changing in a interval, in a small interval, in a geometrical, in a some small amount. Most of our measurement using arithmetic, but sometimes maybe different if in microbiological data different meaning, and also if you are calculating rate of reaction, something here uh, in your calculation, you need to refer to the different types of mean. So here we have three different of mean. We have another example here. In a sensory analysis for taste of two food products, we have the following expert scores. We have five experts and calculate central tendency for each sample. For each sample, we want to calculate the central tendency. Here the expert one for sample one, 5, 5, 5, 4, and 2. For sample 2, 4, 4, 4, 4, and 5. Here, if you're using the central to the mean, you will reach this is 4.2 and this one also 4.2. But you know that basically the data here, if you are a food expert, that you can see, oh, lots of more than half of the experts give the full mark to this sample. But here, the acceptability is not enough. But when you're using the mean for this data, if you use the mean for this data, 4.2, 4.2, yeah, you will reach the same data here. And how you want to compare which sample is better, basically the sample one because most of the expert report its full mark, but here more than half of the experts is not reaching to the full mark for this data, for this sample. So instead here, recently in some article, published article, we see this one for the instead of the reporting the mean, they use mode. Now for the sensory analysis, if you make sensory analysis, instead of the mean, if you mean this is 4.2, this is 4.2. If you report 4.2, it means that both same. But this both sample are different. You can see the experts report the best, the highest mark to this one. But maybe, as usual, one of the experts, for example, if it's durian based, maybe one expert is totally disagreed to durian, to don't like durian, so it's reported too. For this reason, the amount or mean will be decreased. You cannot uh, ignore this data because this is the real data. Sometime in the measurement, if you measure by equipment, if you measure by method, if you reach this data by 2, between 3 5, you can easily ignore this data. But here you cannot ignore because this is the real data, and one expert really don't like your sample. So if you want to report instead of the uh, as a representative for this data, instead of the mean, it's better to using mode. Mode here, when we have the data like this one, uh, in sensory analysis, we report mode. Mode is better representative here. The mode of the data is the more representative data. We have 3 5 here, so the mode is 5. Here we have 4 4, the mode will be 4. So when you report 5 for this one and 4 for this one, it shows the best background of the data. Here the 5 is more representative for this data than 4, so than 4.2. So here also 4 is more representative than 4.2. So here in a sensory analysis, it is better to reporting the um, mode instead of the um, mean, arithmetic mean. So this one, the first the first part of the descriptive statistic, the central tendency. In central tendency, we have mean, median, and mode. You can mostly we are going to use mean, different mean, arithmetic mean, geometrical, or harmonic mean. And also in the sensory, recently it's common to report the mode instead of the mean. Median, when you have outrange data, this is commonly in the um, social science, when they have outrange data, they mostly report the median of the data. For this one also, the median and mean will be same. Median is the in the middle of your data. You arrange from lowest to highest data, 24, 25, 26, and the middle one will be the median. Median also you can report here, but here the best one is this one, using the arithmetic mean. So the first part is um, tendency index, or central tendency, or central index. I have covered here. the next part, here I give you a food sample to measure moisture content. Y is equal to Fx. Y is the moisture content. X is the sample, is the student that want to measure. One group I have girls and another group I have boys. So the girls reported that 24, 25, and 26. Boys reported 20, 25, and 30. Okay, here, if I want to make a representative, uh, because the data is have interval, in a fixed interval or a small interval, 20, 25, and 30, the best way is the arithmetic mean. The arithmetic mean of 20, 25, 30, if you add together and divided by 3, it's exact again 25. So when I want to report the um, 25 for this data and 25 for this data as a representative, you can see here, is it fair? Please reply me in the chat box. Is it fair that I just report the uh, uh, 25 for this one and 25 for this one? Is it fair? And is it exactly showing the real data here? They report 25 and this one 25. This data 24, 25, 26. This data 20, 25, and 30. Is it fair that I report 25 alone for the representative of the data? Please reply me in chat box that are you, is it fair or no that I report just 25 for this one and 25 for this one? Is it fair? Are you okay? You just reply me some student in the chat box that is it fair that I reply oh okay, yeah, it's not fair. It's not fair because some of the, yeah, it's not fair. Thank you. Because this data and this data is exactly same. These two data are exactly the same, but it's not going to show the real representative. Here, for this reason, the central tendency is not enough to report the representative. Here, the central tendency or central index like mean, median is not enough because it's 25, 25, but it's not cover the real data. Here we need the second part of the descriptive statistic, central tendency and dispersion. Dispersion is the second part of the descriptive statistics. Uh, in the description, in the dispersion, sorry, in the dispersion index or measure of variability, different name. Mostly we use range of data, or maybe using the variance of data or standard deviation. Basically, also we have lots of variability index or dispersion index. We have lots of them. Range is the simple one, and maybe we have different type of the measurement measurement of variability. The most common use or most common index in dispersion is a standard deviation, because here in range is very wide. You can see here, if I use the range for this one for the boys with the group of boys, the difference between the maximum and minimum 10, and this one difference between maximum and minimum is 2. The range is for this one is 2 and this is 10. This one, if we use the variance is 25 and this is 5. But because variance is the score of the data and is not um, is not consistent in the dimension for our data, we take root of the variance and standard deviation. Mostly a standard deviation is the best um, dispersion index that we are using commonly. Dispersion index here, if you see that, okay, standard deviation, now you can report that the the girls reported that 25 by 1 unit of standard deviation, and the boys group reported by 5. How mostly in our report we using the plus minus, uh, using um, plus minus to report. Plus minus for the girls we report plus minus 1 standard deviation, and for the boys 5. Now this data is more clear to be as a representative of our data. One index from the central tendency or central index, and one measure or index from the dispersion index. Together we reporting. Sometimes if you report the mode, maybe they use the range or maybe use the other types of the dispersion index, but mostly by mean. If you use mean, um, you report the data here, moisture content instead of the mean. Moisture content equal to 25 plus minus 1, and here also moisture content for this group, moisture content we need to report 25 plus minus 5. And now it shows that the accuracy amount of the amount of the uh, dispersion index, as if it's increased, it means that the accuracy of the measurement is low, and if it's low, it's as low as possible. At the end of the form I will show you one rule of thumb. uh, if it's low, it means that the measurement is accurate and uh, your data is more accurate. Now we have, here we have 25 plus minus 5, 25 plus minus 1. So how we report the descriptive statistic? No, the we report the mean. Always report the mean. It's not always, most of the time. Average value, or along with a measure of variability. Always, it's not meaning that always report the mean. Always report the mean or average value or central tendency together are a standard deviation or standard error of mean. Mostly if you have just one independent variable, it's better to report the standard deviation. We have another type of the common use, a standard error of mean. A standard error of mean mostly using when we have different types of the uh, when we have different types of the more than one uh, independent variable and the nature is different, it's better to reporting a standard error of mean instead of the standard deviation. You learn this one in the statistics, how to calculate the standard error of mean or standard deviation. This one, but you can use the software. For the reporting in the text, it's need to total length of something like this one. Just take from one text. They reported, n number of measurement, average 24.4, and in the bracket it put the s as a standard deviation. They reported 24. You can report like this one, and I prefer, and mostly they prefer to report like this one. Total length of ground truth n equal to the number of your replicate. This one they measure for 128. Maybe you measure for 3 samples, maybe you measure for 5 samples, 2 samples. It depends. Report the number of data averaged, uh, one mean, one central index, and one deviation or one variability or dispersion index plus minus. They report mostly like this one. If the summary, statistic, or descriptor are presented in graphical form, you can simply report the result without verbalizing the summary value. You can see here, if you just want to refer to a figure and want to describe, here just make sure that you report the amount 3.8. No need to put plus minus something because you just reported uh, the uh, the amount. No need to, if you want, you want to refer to a figure. If you refer to a figure and you want to check that it's the difference between or increased, no need to mention that increase by 3.8 plus minus something. No need, just refer directly uh, to the differential between the means if you want to report. If you want to report the frequency data in your text, frequency data should be summarized in the text with appropriate measures such as percent. You can report by percent, proportion, or ratios. For example, during the fall turnover period, an estimate 47% of brown throat and 24% of brook throat were something like. If you want to report the frequency, it's better to report instead of the number, report as percent or proportion or ratios, and instead of the measure that one. If you want to report, for example, if you have 128, do not report here 100 from this one and 20 from that one. Report the percent, report the proportion, or report the ratio. Here I take this one from one of my published article. If you want to report the data in a table, the the data, you can see here I reported moisture content, mean plus minus this one, the standard deviation, and you can see the structure of a table. If you want to report a table here, you need to mention that the values are what? Values are mean. Values are mean. And the number of the replicate or sample n equal to 3 plus minus a standard deviation. This is the this part is the first part of the statistic, is descriptive statistic, and this part is inferential. I will describe later. You can see you need to report and make sure that the number of digit, if you report 10.0 by 2 digit, the standard deviation should be 2 digit. If you report the 1 digit, the standard deviation also need to same amount of the digit you need to report. Now here, if this one be like 30, do not remove this one. You need to put like this one. You know, when you want to report, you need to report the data same digit. So make sure that when you want to reporting in a table, you need to report in a table by same digit. And about the ABCD, I will describe later in the inferential. This is the second part of the statistics. I will describe later. So, so for the reporting the descriptive data, you need to report one mean, one in central tendency, and one variability index. Mostly we are using mean and standard deviation. In if you report the table, if you report the table, you need to describe and you must clear and write what is the value you reported, mean, mode, median, number of replication, and which type of the if here, because I have just one in this table, just I have one independent variable. The concentration of the nano SiO2 must be the the just one fixed variable. I have one variable, so I reported a standard deviation. If you have different type of the variable, for example, you report two. For example, this is the effect of SiO2 nanoparticle on physical properties. Here is here reported like this one. If you have effects of, for example, instead of the SiO2, you use SiO2 and one essential oil, two different types of the um, independent variable, it is better to reporting instead of the standard deviation, need to report a standard error of mean, SE. And we write here mean plus minus SE, standard error of mean. So this is as you reported in a table, and this part is the first part, the descriptive statistic. If you want to report in a graph, this graph also from the same. This is from my published article also. From the same data, here it's reported effects of SiO2 nanoparticles on mechanical properties and heat seal strength of like this one. You need to first put and don't forget that table description and should become up, detail below the table, the name of table coming up, the detail and the statistical description coming down. Here it need here we have the figure, name and description and the statisticals all coming down. We have not anything above the figures, should be right down, and the table should be the title of the table coming up and description and statistical description coming lower. And maybe other description if any other symbol need to clear over there. Here you can see we report the title of the figure is until here, and from this one we have two parts reporting on a statistical. This is the descriptive statistic. Bars, each bars represents the mean. This is the mean amount of the mean, and n equal to 8, number of replication plus minus standard deviation. This is, this one, the error bars. How to put the error bars on the chart. Yeah, if you want to report as a figure, you need to report mean plus minus standard deviation. Here, different figure. Yeah, this figures, mostly I use GraphPad to do this one. It's very clear, and I like this type of the standard deviation and also the error bars. Um, so here is uh, the first part, our descriptive statistic. Now, going to the second part, the inferential statistics. Here in mathematics, uh, when we say 26, 25, we can easily write that 26 is higher than 25. There is nothing. We cannot say that 26 is less than 25. 26 is higher than 25 here. 26 is higher than 25. And we write 26 is higher than. It is in mathematics. But in statistics, you report 26 plus minus 1.2. This is the mean and standard deviation. 25 plus minus. Here you cannot say easy that is it higher or not. Maybe they are equal, and the errors coming to show the different amount of the mean. So you cannot easily say that 26 higher than 25 here. It is uh, in the statistic we say that they are different. 26 and 25 is different, but in the statistic you cannot say that this is significantly different. In a statistic we need to report, is this differences is significant or no. Here we need to report that is it significant or no. So we need inferential statistics. Inferential statistics is about the test that is this mean this mean is higher than this one. Is this any difference? Is this any significant difference between these two means or no? Or this one you need to report in the second part of the statistics. So you understand that here in the statistic, because in the practical data you have not a fixed value, you have a range of value. 26 plus minus 1.2, here 25 plus minus 0.6. It's not a single point like mathematics, right, that 26 is higher than 25. In the statistics, you need to mention, you need to check, you need to test, is this range is different with this range or no. If it's the test is positive, then you can report that they have statistically different or significantly different this range of data from this range of data, or this range is higher than this range. So we need inferential statistic to check and measure and report that the differences between the means. Here in the mathematics, you easily say that 26 higher than 25, but in the statistic, you cannot say 20 in this is this range is higher than this range or no. You need to test this hypothesis. Is it different this range is different than this or not. Okay, the second part of the statistic is inferential statistic, test of hypothesis. In a statistical research, a variable is defined as an attribute of an object of a study. Choosing which variables to measure is central to good experimental design, the type of the variable. You need to know which type of variable you are working with in order to choose appropriate statistical test and interpret the result. You know, for the test of hypothesis, if you want to use different tests, you need the behavior or types of the variable. You can usually identify. So basically, if I want to choose one test for the statistical analysis for inferential statistics, we need I need to know what type of variables I am working with. So basically, understanding the types of variables helping you to choose the right statistical test. You can usually identify by these two questions. If when you want to describe and you want to find the type of your variable, what type of data does the variable contain? What part of the experiment does the variable report? No, what type of data and what part of the experiment? This part, what part means that dependent variable, independent variable, which part? You change this variable to measure this variable. This is showing you what is your, what part of the experiment, dependent and independent variable. Here, what type of data the variable contain? This variable contains which type of data? So by these two questions, you can find your types of variable. Types of data, it's categorized as categorized in two different quantitative and categorical variables. So in type of variable, the first one, type of variable. Type of variable is quantitative and categorical. Quantitative data represent amount. The data is quantitative amount. They report the amount. And a variable that contains quantitative is quantitative variable. This is the definition of the quantitative variable. A variable that contains quantitative data, it is quantitative variable. A variable that contains categorical data is categorical variable. Categorical data represent grouping. This is group represent the grouping. This is represent the amount. The quantitative, is it quantitative or is it categorical? Quantitative variables we divided into discrete variables and continuous variable. Discrete variable, it's basically coming from the counts, number of the student in a class. It is quantitative, but a number of a student in a class and continuous variable, measurement of continuous of non-finite values. The quantitative data, mostly in the statistical software, it's both categorized as same, is numerical. Both is numerical or quantitative. But there is a difference between the discrete and continuous. Here the number of students. We have, for example, 22 students. We have not, or maybe 23. We have not 22.3 students. We have 22 students. But in the distance, when we measuring, It is 20 kilometer or maybe 22 kilometer or maybe 22.22 kilometer. We have continuous data here. Both are categorized as quantitative. So if we have quantitative data, mostly it's discrete or continuous data. And if we have categorical data, we have three different types of categorical data: binary or dichotomous data, variable, binary, yes or no, head or tail, win or loss. This is just two options in the binary variable. Or we have nominal variables. In nominal variable, with no rank, there is no rank. For example, we have gender, maybe it's an or maybe a spice's name, colors, brands. This one are categories, or maybe second year student, fourth year student, or maybe we have or maybe we have different like this one, or maybe we have original variable, finishing place in a race for second place, first place, second place. Is it? But in food technology, mostly we have nominal variable. Mostly we are going to use in the categorical variable, nominal variable, and also we have this one. Mostly we measure the continuous variable. This is continuous variable. Mostly we have a nominal variable. Original binary, mostly it's coming in the social science or maybe in other science. But in food, mostly we have nominal variables in categorical and continuous variable in the quantitative variable. And second part of the second question, the first question, the type, which uh, what type of data, what part of the experiment. So in the variables categorized based on the type, quantitative or categorical, and also based on the which part of the experiment, independent vs dependent, dependent or independent. For example, here the effects of lemongrass essential oil on physicochemical and mechanical properties of gelatin edible film. This is one research that I am looking for the variable, which part of the experiment. Here we have independent variable or treatment variable or maybe predictive variable. This is dependent variable or response variable. We have independent variable, dependent, and also we have control variable. Mostly we in the material and method, we need to clearly say that what is our independent variable, what are our independent variables, and what are the dependent variables, and what we control. For example, here lemongrass essential oil Leo, I put Leo. Leo concentration is my independent variable. I can change the independent variable here. Leo concentration is my independent variable. Dependent variable, mechanical properties, physical properties, chemical properties, or other property that we want to measure is dependent variable or response variable. And control the amount of plasticizer, gelatin concentration, temperature of casting, relative humidity, everything that we have fixed, we need to describe as control variable. We control um, our system. That just showing the effects of independent variable on dependent. For example, if you forget to adjust the plasticizer, it will be effect, and we cannot detect that this effect is coming from Neo or from plasticizer. Gelatin concentration also, temperature of casting also. Many things you need to control to exactly extract the effect of the independent variable on dependent variable. And if you want to know about the types of the this variable, the concentration is basically, concentration uh, is a quantitative, because the concentration is quantitative here. And it is continuous because you can use zero point 0.1, you can use 0.2%, you can use 2%, 10%, different data you can. This is the but because we cannot here, we cannot manipulate, we cannot use all concentration in the to measure the independent variable. Here we we choose some special, or maybe based on the preliminary experiment, or maybe based on the literature, we use, for example, 1%, 2%, 3%. So in this case, we change manually the type of the variable. Here the type of variable we change manually from the concentration is quantitative, but when we use 1%, 2%, 3%, just a special amount, we manually change the type of the variable from quantitative to categorical, and it's nominal. Now 1% is a nominal and 2% is a non-nominal, 3% is one nominal, because we are not going to measure between each point. So here low concentration basically is a quantitative, but if we fix the data for measuring, we change it as category. Mechanical properties, because we are measuring equipment measure, it's exactly quantitative. Physical exactly quantitative. Chemical exactly quantitative. It's all quantitative. This one also is a fix, and we are not going to cover. So you need to know about the types of the, is it independent, is it dependent, independent, dependent. Is it quantitative? Is it qualitative? I'm sorry, it's categorical. We are not going to do qualitative. Quantitative category. Is it one? This is basically quantitative, but we change to category. For drawing a chart, don't forget, if your independent variable is continuous, is quantitative, is your if your independent variable is quantitative, and your dependent variable mostly is quantitative because we are measuring. If most quantitative, we need to draw the figures by a scatter in this in the Excel file if you want to do a scatter. But if we change manually to the this one, if we change manually the concentration to fixed concentration amount, we need we must report is a column and or bar chart. You cannot report this one as line chart because you manually change the type of the data. Here you can see my represent, you can see the concentration of nanoparticle here is originally it is quantitative, but I am changing this one as categorical. 0%, 1%, 3 and 5. So I must draw a chart by bar chart. I cannot do it is as a line because I have not covering between 0 and 1. I don't know what's happening here. Just I have the data for 0. Just I have data for 1, 3 and 5. For this reason, I must draw the chart by bar chart. I cannot report this one as line chart. Instead of this one report as line chart. This is not line because the line chart need to both of the this is the independent variable and dependent variable should be both are in quantitative if I want to write to draw a line chart. And another tip That don't forget that all time. Independent variable must coming to the horizontal line, and dependent variable measurement, every measurement coming to the vertical one. You cannot change this one. This is, if you change this one, like you're wearing your socks over your shoes. You cannot do that. You can do this one. You can wear your socks over your shoes, but don't forget that it's not uh, popular. That is the people that wear the people first wearing the socks and after that wearing the shoes. So don't forget that if you want to draw the chart, the independent variable coming to the horizontal and dependent going to the um, vertical part. Okay, so in the statistical test, we need to choose the right statistical test based on the category, based on our variable, dependent and independent. This chart will help you. This is, you can also look into this website Scriber. I bring this one from the Scriber. Here, I make it a little bigger. Okay, this is the whole way. This is for, as you know, this is, we have parametric analysis and we have non-parametric. I'm not going to this advanced part now. Most of our data, if it's coming from the measurement, our equipment measurement, most of them is basically they have categorized as parametric test. But sometimes maybe in the measurement, if the data is low, the amount of data is low, over there we have non-parametric test, is different types of the test, and totally different. But regularly for 90% of our sample, we use this flow chart. This flow chart. Predictor variable um, or independent. Predictor is independent. Predictor variable categorical or quantitative. Is it categorical or quantitative? If it's categorical, we follow this one. If it's quantitative, we are following this one. So if the independent variable is categorical, outcome variable is dependent. Outcome, okay, first we have categorical. So here we have categorical. Our outcome is, or independent variable is quantitative or categorical. If it is again categorical, both categorical. For example, mm, in the genetic, maybe they're using this one, this type. But if both categorical, independent variable categorical and dependent variable categorical, we use chi-square test. This one. If categorical for the independent variable and our dependent variable is quantitative, okay, we need to do a comparison test. We need to do comparison test. Okay, here how many groups are being, then we need to check that how many groups. If two groups, we choose t-test. If more than two groups and outcome variable are one, we use ANOVA. If outcome variable more than two or dependent variable more than two, it's better to use MANOVA, multi-way analysis. So we choose based on our variable, we choose easy. Okay, one question here: if two groups are being compared other than t-test, one randomized still be used. If we have two groups, we can use the ANOVA, but it is better to using the t-test. If we have just two tests is if we have two groups, the best result coming from the t-test. You need to. It is better to adhere to this one. To if we have two groups, we need to use t-test. If we have more than two groups, we need to use ANOVA or MANOVA. Here, another thing is if it's quantitative, our predictor or our independent variable is quantitative. Outcome variable or dependent variable is categorical. This is quantitative, this is categorical. We are using logistic regression. If both quantitative, for example, we are measuring the weight over height, we want to make sure that both are quantitative, changing different weight, different height. Both quantitative if how many predictor we have. If one, just simple regression between these two, between weight and height, we can make a regression. If we have more than one predictor or more than one independent sample, we use multiple regression. We use multiple regression. So these are the tests. Chi-square, you need to know, t-test, ANOVA, MANOVA, simple regression, multiple regression, and logistic regression. It's based on the um, types and behavior of of your data. First, you need to detect your predictor or your independent variables, categorical and quantitative, and then based on that, choose uh, the right test for make sure that which test is measuring your differences between the samples. We have two other type. It's commonly using in food. If you have sampling one independent variable, we have if you have sampling before and after a treatment. For example, we want to do one nutritional effect. We measure the weight, blood pressure, or maybe something before, and then they feed to the um, human, or maybe feed to the animal, and again we test before and after. We have we need to use paired sample t-test. This is another type of t-test. We have measuring before and after. We have one independent sample. For example, I want to measure the blood pressure effect of one nutritional material to on blood pressure. We measure blood pressure, then we feed. After that, again we measure. One independent, it's double time. We must using the t-test. And also, if you repeat the sampling during time, this is commonly the food preservation. If we want to do the food preservation um, in different time, for example, we want to measure the shelf life of one food material. We measuring some characteristic from the first day, again 1 week, maybe after 2 weeks, depend on the food material, maybe 1 day, 2 day, 3 day, maybe it's 1 month, 2 months, 3 months. If we repeating more than one time, if one time you repeat it, paired sample t-test is okay for you. If you repeating during the time, you measure more than two times. If it's before and after, t-test is okay. If it's repeating for more than two times, or maybe you are doing some medical test for cancer people, you take medicine and you take some maybe something in the blood count, something over there. you measure during the time. Maybe after 2 months, after 3 months, you measure again after 3 months. And if it's repeated, you must use the repeated measure. You We have different type of the ANOVA here. Maybe sometimes using the mm, univariate, or maybe different type of the ANOVA over there. Some people sometimes confusing and using the ANOVA for repeat instead of the repeated measure. But if you are if one of your independent sample is time, it means that you are measuring during the time. You need to use repeated measure test. You need to use repeated measure test. All of these tests, all of these tests are parametric. If you are interested to non-parametric, maybe you can read yourself, or maybe we can have another workshop for non-parametric. This is basically how we can detect that is this parametric or non-parametric. It's based on the homogeneity of the data that we are going to take in our data, because we are measuring from the based on the equipment, or maybe measuring something based on the data. So mostly our data is homogenized in food technology, but other sometimes they are using the sometimes they report something from the other science like social science, humanities. They use the non-parametric test, and they have uh, for all of this they have replacement. For example, instead of the t-test, they have human Whitney, or maybe ANOVA. They can use um, uh, some other testers here. All of this have their another test, on non-parametric test. If you want to report the inferential, so this is the last part. Around maybe 5 minutes we'll finish. The result in table, you know how to report in the take. The results in the bracket table 1 show that water solubility and moisture uptake. Water solubility and moisture uptake significantly decreased. How they detect the significantly decreased? Based on the inferential test that we use. This one here, we have one, here we have one independent sample. The independent sample is categorical. It is basically quantity, but it is categorical. It's one, and you can see here more than here more than two level, more than two groups. One, two, three, four groups we have here. This is independent and it is categorical. And we measure, this is the quantitative. So here we need to use ANOVA. One way ANOVA for this one. We use one way ANOVA just for water separate. Each of them reported separate. So here, when when you test through the statistical test, and you found that this is different, 8.6, then be different than this one, different, you need to put the different letter A, B, C, D, A, B, C, D. And as I recommend for all of you, uh, use the lowest, the first letter for the highest level. You can see here, 8 is the highest one, and I put A for this one. Here, 14 is the highest one, I put A for this one. It should be have, no, it should be in the same arrange, the first letter coming for the higher. Or if you want to put the first letter for the lower, you need to do for all. You cannot put this one starting from A from the lowest, this one starting A from the highest. You need to be consistent in the putting the letters. And you can see it for this one, and reported here significantly decrease. Uptake significant. Why significant? Because it's A, B, C. If all A, it is different, but it's not significant. And make sure that we are using which level of probability. Mostly as a default, we're using 0.05 level of probability. So we report p lower than lower than 0.05 means significantly decreased. If not significantly decreased, you need to mention that p equal or higher than 0.05. Here in the text, or also here, the effect of ZNO nanoparticle nanorod on TG of film summarized in table 1. You can show like this one. In the results indicate that addition of significantly shifted p equal lower than 0.0. If not significantly, if shifted but not significantly, you need to put p higher or equal to 0.05. This one you can see it significantly decreased A, B, C. And the table here you need to put the here values are mean and the number of replication plus minus standard. This is the first part of statistic, the descriptive statistic. This one, this sentence is very important. This is the inferential statistic, meaning different letters in each column. Each column. It means that I measure each column separately. So I am not going to measure all columns together. Each column represents significant difference at 5 level percent of probability. Sometimes they write 5%. This is meaning this one, 0.05. Sometimes they write that represents significant difference at 95% level of here this is a probability. Then that one sometimes they're using the confidence level, 95% of confidence level. Sometimes they write as 5% level of probability, or sometimes they write 95% level of confidence level among SSPS film properties. No, this one between them. This is not SPSS. This is SSPS. One soluble soy protein, soluble soy protein soya something. SSPS. This is a one type of the film. This is not do not be confused that this is not SPSS. This is SSPS. Is one food material, one primary food material. This is. So different letter in each column represent this is the meaning of that you use the complement. You know, in figures in the tables you need to mention a descriptive statistic and inferential statistic together is meaning that you're reporting your analysis in correct way. So if you want to report, you need to check all of your tables, all of your figures, and then report it correct. I just give you one rule of thumb that mostly the journals or maybe your supervisors or maybe the expert that they are caring about this one in the practical, not in the humanities or maybe social science, or maybe even it's not this is not valid even in the sensory analysis. It is valid for the practical data that we are measuring by equipment or instrument. If a standard deviation is higher than 10% of mean, need to check and repeat the experiment. It means that here 12 10% of 12 is 1.2. If this one the amount of the standard deviation is higher than 1.3, you need to repeat the experiment. You need to check your data. This data is have some bias, have some uncertainty, not higher. This is rule of thumb. This is not, um, it's not totally accepted by all, but for for most of the journals and for most of the experts, they check. If you want to check your data, here you can see this data. This is 89. If this one is more than 8, this data is not valid. So need to check that at least. Check your data, and if you want to, if your standard deviation is higher than 10% of the mean, it is better to check your data or redo your experiment, repeat experiment until you reach to the uh, around percent less than 10% of the mean. This is the rule of thumb. Just I want to check it. If it is lower than 10% of the mean, nobody caring, nobody asking any other question. But if it is higher, you need to check. And if again you have higher level of the uncertainty or the variability, you need to again repeat, or maybe if you again check and you found that it is still higher, you need to have the reason why this is happening. So this introduction is coming to finish here. I hope you learn and I increase something to you. Here I want to again show you that here if you want to report a figure, make sure that you put the letter. This letter need to meaning here. Bars represent the mean plus minus. This is the descriptive statistic. This one is different letter on each bar shows significant difference at 5% level of probability. Different letter in each bar, different. It shows that this is the significant difference. This means that this mean is higher than this. This mean is higher than this. But this two, you can see this C and C. This two is not different. This is means that the 0% and 1% have not enough amount of the effect on the here on young modulus. Or also here, if you can see on the tensile strength, also there is no effect between 0 and 1. Here you can see this is the statistical analysis. This is around 35 and this is 30, 31, but it's still same. It's still same. It means that the statistical analysis shows that between these two there is no significant difference. For this reason, I put both A and this one put both C there. And as I told you, you need to start from the higher amount, starting by the first letter A. But this one you can see is starting from A from this one. Need to be consistent to reporting. So in each, if you want to report a good result, you need to have mean plus minus standard deviation and also including the inferential statistical analysis in both tables. Same in tables, you need to report same thing. You can and the last thing, do not report the data in your report as both one time as table and another time as a figure. Just must report one time, just in table form or just in a figure form. um, my side already finished, and if you have any question, I'm here to respond the question to your question. You can write in the chat box or you can open your microphone to ask any question if you have. If you have not any question, you can enjoy your time and take your time. And also, you can find this video on the on my YouTube channel. You can come over there, subscribe to my YouTube channel, and you can receive. I will do one by one the different tests, how to do different tests and how to interfere the test by analysis. I will try to upload one by one, and you can receive over there. You can easily find my YouTube channel by my full name. uh, if you know my full name. If you're looking my full name, you can over there you can find my YouTube channel. Please come over there and watch other videos. I have also some other related videos maybe useful. If question, I'm here. I just stopped the recording. Thank you so much for giving me this chance to record.